Hello everyone, welcome back to my channel. This is the continuation part of hyperbolic functions. So in this video we will learn some results of hyperbolic functions. So the first one is sine hyperbolic 0 which is equals to 0. That means we know the formula of sine hyperbolic x. So in that x place we will replace 0 and we will solve the values. That means e to the power of 0 minus of e to the power of minus 0 upon 2. So here which is equals to, we know the value which is e to the power of 0 equals to 1. So 1 minus of 1 upon 2 which is equals to 0 by 2. So here we got the value as 0. That means anything upon any value means 0 upon any value is equals to 0. Then similarly we have the other result which is cos hyperbolic 0 is equals to 1. Similarly we will follow the cos hyperbolic x formula. In that x value we will replace 0. So we can write it as e to the power of 0 plus e to the power of minus 0 upon 2. So 1 plus 1 upon 2 is equals to 2 by 2 which is 1. So the next result is tan hyperbolic 0 is equals to 0. Now we know the formula of tan theta is equals to sine theta upon cos theta. The same formula we will write it here, that is tan hyperbolic 0 is equals to sine hyperbolic 0 upon cos hyperbolic 0. We know the sine 0 value is 0 and similarly the cos 0 value is 1. So 0 upon anything is equals to 0. Now the fourth result is cosec hyperbolic 0 is equals to infinite. So we know the reciprocal of sine is equals to cosec hyperbolic x. That means cosec hyperbolic 0 is equals to 1 upon sine hyperbolic 0. So we know the sine hyperbolic. Here I have written sine 0 is equals to 0. So here we can write it as 1 upon 0. Anything upon 0 is equals to infinite. So these are the four results and there are two more results. Let me highlight this one. The sine hyperbolic 0 is equals to 0 and the cos hyperbolic 0 is 1. Then tan hyperbolic 0 is 0 and the other one is cosec hyperbolic 0 is equals to infinite. Similarly, let's go for the fifth one. So these results will be useful when we will solve the problems. So the next one is sec hyperbolic 0 is equals to 1. So by the reciprocal term of sec theta is equals to 1 by cos theta. So I can write it here as sec hyperbolic 0 is equals to 1 upon cos hyperbolic 0. So the cos 0 value is 1. So 1 upon 1 is equals to 1. Now let's go for the sixth result. That means coth hyperbolic 0 is equals to infinite. That means coth hyperbolic 0 is equals to 1 upon tan hyperbolic 0. Also we can use the cos hyperbolic 0 upon sine hyperbolic 0, but I am using the reciprocal value. So 1 upon, then the tan 0 value will be 0 only. So anything upon 0 is infinite. So these are the 6 results to be learned and remembered so that we can use these one in the practiced questions. So let's learn some more formulas of hyperbolic functions. So the first one, let write it as formula 2. Under that we will learn some formulas. So in the formula 2, let's learn the formulas of hyperbolic functions. The first one is sine hyperbolic 2x. Okay, so the sine hyperbolic 2x formula is equals to sine hyperbolic x into cos hyperbolic x. So this is the formula. So we will prove this one, then we will go for the other formula. So the first one is, let's try to solve this from the right hand side. As we know, the sine hyperbolic x is e to the power of x minus e to the power of minus x upon 2 into e to the power of x plus e to the power of minus x upon 2. So these two value gets cancelled out and the remaining one will be written as e to the power of x minus of e to the power of minus x into e to the power of x plus e to the power of minus x. Now let's multiply these terms. So on multiplying, we get e to the power of x into e to the power of x plus e to the power of x into e to the power of minus x minus e to the power of minus x into e to the power of x minus e to the power of minus x into e to the power of minus x upon 2. Simply, I just multiplied e to the power of x with this term and again minus of e to the power of minus x with the similar term only. Now we can write it as e to the power of 2x plus e to the power of x minus x. That means here if you see the formula of exponential, a to the power of x, a to the power of y will be written as a to the power x plus y since the base is same. So in the same way, I can write e to the power of x into e to the power of minus x. That means e to the power of x minus x. So here e to the power of 0. And we know when the power is 0 in the exponential form, the value will be 1. Suppose consider 5 to the power of 0 is nothing but 1. And similarly for 100 to the power of 0 is nothing but 1. In the same way, here we will get the e to the power of 0 value also 1. Then minus of e to the power minus x plus x, which is 0 only, minus e to the power minus x, that means e to the power of minus 2x upon 2. Now, so if you see here, these values will be 1. So this value is 1 and this value also 1. So plus 1 minus 1 gets cancelled out here and the remaining will be e to the power of 2x minus e to the power of minus 2x upon 2. If you see this one, this is in the form of sine hyperbolic x formula. In sine hyperbolic x formula, we write the formula as e to the power of x minus e to the power of minus x upon 2. Isn't it? This is sine hyperbolic x. So in this formula, we have 2x. That means the x is replaced as 2x. So I can write this one as sine hyperbolic 2x. So this is the formula of sine hyperbolic 2x. Now we can also find the alternative way to get the sine hyperbolic 2x is equals to sine hyperbolic x into cos hyperbolic x, which takes only few steps to solve. That is, if you see here, to solve the sine hyperbolic 2x is equals to, I can write this one as sine hyperbolic x plus x, because if you see x plus x is equals to 2x. So I can split this 2x as x plus x. Now this is in the form of sine hyperbolic a plus b form. We have the value and we know the value for the sine hyperbolic a plus b, which is nothing but sine hyperbolic A into cos hyperbolic B plus cos hyperbolic A into sine hyperbolic B. So this is the formula for the sine hyperbolic A plus B. So I can write this one as sine hyperbolic x into cos hyperbolic x plus sine hyperbolic x into cos hyperbolic x. So which is equals to 2 sine hyperbolic x into cos hyperbolic x. This is what we got. The alternative way to solve for sine hyperbolic 2x. Also, we have the other formula for sine hyperbolic 2x, that means 2 tan hyperbolic x upon 1 minus tan hyperbolic square x. So for sine hyperbolic 2x we have two formulas. We have already solved for the 2 sine hyperbolic x into cos hyperbolic x. Let's solve for the other one. So the next second one is sine hyperbolic 2x is equals to 2 tan hyperbolic x upon 1 minus tan hyperbolic square x. So for this we will solve from the left hand side. What is there in the left hand side? In the left hand side it is given that sine hyperbolic 2x. So we know the value for sine hyperbolic 2x, that is 2 sine hyperbolic x into cos hyperbolic x. And we have to get the RHS side value. If you see here, the whole term is in the form of tan hyperbolic. So for that, we know for tan hyperbolic, or consider tan theta is equals to sine theta upon cos theta. So to get this one, if I multiply and divide cos theta, we can get this term. See here, 2 sine hyperbolic x upon cos hyperbolic x into cos hyperbolic x into cos hyperbolic x. So in this step, I just multiplied and divided cos hyperbolic. Okay, now we can get 2 tan hyperbolic x into cos hyperbolic square x. So now let's solve for the next step, 2 tan hyperbolic x. If you see here, we know cos theta is equals to, we have cos theta is equals to the reciprocal of sec theta. So I can write it here as 1 upon sec hyperbolic square x. Okay, then 2 tan hyperbolic x upon, and we have a formula for this, that is sec hyperbolic square x plus tan hyperbolic square x is equals to 1. Then sec hyperbolic square x is equals to 1 minus tan hyperbolic square x. Okay, then here we got the two values of sine hyperbolic. So here we have the two values of sine hyperbolic 2x formulas. We have these two values. Now let's go for the cos hyperbolic 2x value. Now the third one is, we will find cos hyperbolic 2x formula is cos hyperbolic square x plus sine hyperbolic square x. So this will be proved by using the right hand side values only. Let's solve this one as cos hyperbolic x whole square plus sine hyperbolic x whole square. And we know the formula for cos and sine. That means hyperbolic function formula, e to the power of x plus e to the power of minus x upon 2 whole square plus e to the power of x minus e to the power of minus x upon 2 whole square. Then, so which is equals to 1 by 4, because 1 upon 2 whole square, which is nothing but 1 by 4. So here we get, then we can write it here as e to the power of x plus e to the power of minus x whole square plus 1 by 4 e to the power of x minus e to the power of minus x whole square. Then take the 1 by 4 as common and we get as e to the power of x plus e to the power of minus x whole square plus e to the power of x minus e to the power of minus x whole square. Then this is in the form of, if you see, since a plus b whole square plus a minus b whole square is equals to 2ab. That means here I am writing the formula a plus b whole square plus a minus b whole square is equals to 2a square plus b square. So consider this as our a value and this is our b value. Okay, in the next step I will write it as 1 upon 4, then 2 into e to the power of 2x, because here it is in the square form, so 2x plus e to the power of minus 2x, then 2 ones and 2 twos are, then I got e to the power of 2x plus e to the power of minus 2x upon 2. So this is in the form of cos hyperbolic x formula. Only in the place of x it is replaced as 2x. So I can write it as cos hyperbolic 2x. So this is what we got the value and we have solved this one. So cos hyperbolic 2x is equals to cos hyperbolic square x plus sin hyperbolic square x. Now let's go for the next formula, and we have also this one, for to solve this one we have other alternative form in a short way. If you want you can solve this one as from the right hand side, that means cos hyperbolic 2x. I can write this one as cos hyperbolic x plus x. Then here I will use cos hyperbolic a plus b formula. I am using cos hyperbolic a plus b formula, that is cos hyperbolic x into cos hyperbolic x, since here only x value is variables are present, then plus sin hyperbolic x into sin hyperbolic x, then which is equals to cos hyperbolic square x plus sin hyperbolic square x. Now let's go for the next formula. That means there is a formula of cos hyperbolic 2x is 2 cos hyperbolic square x minus 1. So the first formula for cos hyperbolic 2x is sin hyperbolic square, cos hyperbolic square x plus sin hyperbolic square x. This is one of the formula for cos hyperbolic 2x. The other one is 2 cos hyperbolic 2x minus 1, and the other one is 1 plus 2 sin hyperbolic square x. So we have already proved for the cos hyperbolic square x plus sin hyperbolic square x. Now let's go for the second one. So the second one is, which is given, cos hyperbolic 2x is equals to 2 cos hyperbolic square x minus 1. So in order to prove this part, we will take the help of the following identities as cos hyperbolic square x minus sin hyperbolic square x, which is equals to 1. Then if I write this one as cos hyperbolic 2x is equals to cos hyperbolic 2x plus sin hyperbolic 2x. then which is equals to, here I can write it as cos hyperbolic 2x plus cos hyperbolic 2x minus 1. I have written here the first formula of cos hyperbolic 2x formula. Then I have substituted the value of sin hyperbolic 2x as plus cos hyperbolic square x minus 1. Then 2 cos hyperbolic square x minus 1. Then we got the second one of cos hyperbolic 2x formula. And the next one is cos hyperbolic 2x is equals to 1 plus 2 sine hyperbolic square x. Then for this also we will follow this one, cos hyperbolic square x minus sine hyperbolic square x minus square x is equals to 1. So to solve this, we know the first formula of cos hyperbolic 2x, which is cos hyperbolic square x plus sine hyperbolic square x. Let's replace this value as 1 plus sine hyperbolic square x plus sine hyperbolic square x, and then see here I just use this identity of hyperbolic function, then I just change this cos hyperbolic square x as 1 plus sine hyperbolic square x, then I can write it here as 1 plus 2 sine hyperbolic square x. So these are the values for cos hyperbolic 2x, and there is one more formula for cos hyperbolic 2x, that is, here I am writing the one more formula, which is nothing but 1 plus tan hyperbolic square x upon 1 minus tan hyperbolic square x. So let's solve for this one also. We will prove the value. See here, cos hyperbolic 2x is equals to 1 plus tan hyperbolic square x upon 1 minus tan hyperbolic square x. Then by using the formula of cos hyperbolic 2x formula, which we got here is the first one. The first one is cos hyperbolic 2x plus sine hyperbolic 2x. So by using that, we can write it as cos hyperbolic 2x is equals to cos hyperbolic square x plus sine hyperbolic square x. By using the first identity of the cos hyperbolic 2x, we can convert this formula. Just divide and multiply cos here, so that we can get the tan value, because we know tan theta is equals to sine theta upon cos theta. So to get that one, we can multiply cos and divide cos in this equation. That means in the right hand side. So let it write it as cos hyperbolic square x plus sine hyperbolic square x upon cos hyperbolic square x into cos hyperbolic square x. Then this value will be in the form of tan. So cos hyperbolic square x plus tan hyperbolic square x into cos hyperbolic square x. So if you see here, by taking the tan common, by taking the cos hyperbolic x value as common, then I can write it here as cos hyperbolic square x 1 plus tan hyperbolic square x. So we got the numerator value of the formula of cos hyperbolic 2x. Then to get this one, let's change the cos hyperbolic square x value. That means by changing this one, we can write 1 by sec hyperbolic square x. Just the reciprocal formula of cos theta, that means cos hyperbolic square x, then 1 plus tan hyperbolic square x. We can change this sec hyperbolic square x as 1 minus tan hyperbolic square x by using the identity of sec hyperbolic square x plus tan hyperbolic square x, which is equals to 1. So by using that, I can write it as 1 plus tan hyperbolic square x upon 1 minus tan hyperbolic square x. So this is the formula of cos hyperbolic 2x. We have 4 formulas for cos hyperbolic 2x and 3 formulas for sin hyperbolic 2x. Sorry, 2 formulas for sin hyperbolic 2x. And next we will go for the tan hyperbolic 2x formula. The next one will be tan hyperbolic 2x formula, which is nothing but 2 tan hyperbolic x upon 1 plus tan hyperbolic square x. So let's prove from the right hand side. By proving from right hand side, we will get the left hand side value, as we have tan hyperbolic 2x is equals to tan hyperbolic x plus x. So we know the formula of tan hyperbolic x plus y formula. So which is nothing but tan hyperbolic x plus y is equals to tan hyperbolic x into tan hyperbolic y upon 1 plus tan hyperbolic x into tan hyperbolic y. So this is what we have, one of the identity of hyperbolic function. By using that, we can write it as just tan hyperbolic x into tan hyperbolic x upon, since here we have x and y value, so I have written here x and here I have written y. Here we only have the x value, so I can write it as tan hyperbolic x into tan hyperbolic x plus 1 plus tan hyperbolic x into tan hyperbolic x, then which is nothing but 2 tan, I just written a mistake here, which is plus we will get. So 2 tan hyperbolic x upon 1 plus tan hyperbolic square x. So this is what we got here, the formula of tan hyperbolic 2x value. Then we will go for the other formulas like sin hyperbolic x plus y plus sin hyperbolic x minus y. It will be in the form of x plus y or a plus b in the form. So in the next video we will discuss about those formulas, and that's it for today. Thank you.